Well, greetings everybody. Back at my board here. I haven't been doing these quite as frequently. I've been out doing summer stuff, kayaking, canoeing, and backpacking, so on and so forth, doing stuff with the family. So these are not coming along quite as frequently as they were in the winter. But anyways, this is one that we did earlier, and I'm going to just rehash some of this stuff. And I want to do a little bit more on what's called the radians, the radian type of way of solving curves. I got into that the last lesson 23, and it got embedded with a whole bunch of the horizontal curve stuff from the traditional way. So we're going to review a little bit of this stuff and try to make it a little more clear for you all. And so this is one of the circles that we used previously. So I'll go over some of the things that we have here. So it's full circle. Full circle is 360 degrees, and that's 100% of the circle. So 90 degrees is 25% of the circle. 180 degrees is 50% of the circle. 270 degrees is 75% of the circle, and so on and so forth. In this particular one, we have a diameter of 120, we'll call it feet, call it meters, call it miles, whatever you want to call it. Diameter is 120, so half of that is the radius, and that's 60. So we have 60 feet, and then to solve, say we want to solve the curve, maybe we have a 52-degree angle. This is what we did, so we're going to quickly go through it all so that when we do the radian part of it, it'll start to make a little sense. So 52 degrees is a percentage of 360 degrees. So what you'd want to do if you want to solve it the traditional way, 52, enter, 360, divide. And then you want to take the circumference. You're going to know the circumference because you have the radius. Radius times 2 is the diameter. Diameter times pi is going to give you that circumference. So then you're going to go, and I already have that stored as 1, and then times. And so our curve length for a 52-degree angle for a 60-foot radius is going to be 54.4543. And I've stored that as 2. So that's how you solve the curve length from the angle. Now we want to solve the angle from the curve length. We'll do it more or less the same way. Well, 54.4543. So we have that stored as 2. We'll go recall 2. Yep. Enter. Then we're going to go recall 1 is the circumference. And we'll go divide. And that's 0.144. Now we're going to multiply that times 100% because our circle is, or times 360, sorry. Times 360 degrees. And that gives us 52 degrees. Now we're back. That's how we do that. So we've solved curve length, and we've solved the angle from the curve length. So curve length from the angle, then we solved the angle from the curve length. Now what we did is we also broke down the triangle itself into this is a delta angle. It's an oblique triangle. If you go back to the earlier lessons, we solved oblique triangles. One of the ways to find the chord is you could do the law of cosines, a squared plus b squared minus 2 times a times b times the cosine of the angle, which is 52, and then take the square root of that, and then minus that, and then take the square root of that. That gives you 52,6045. The other way to do that is to solve a right triangle. So you're going to split this delta. Now we've got 2 even right triangles there. That's what this sign is. A little square sign means it's a 90 degree, it's a right angle. And then there's 2 ways to solve. We're going to solve these 2 over here. And the way to do that, of course, we have our radius is 60. We don't have this one, which would be the cosine. And we don't have the sine, but we want the sine. So we're going to split 52 in half. That's going to give us 26 degrees. So that's 26, enter. Now what we're looking for is the opposite over the hypotenuse. That's the sine. So you want to go 26 degrees. Now you want the sine of that. It's 0.4384. Now you're going to multiply it times 60. And it's 26,3023. So you double that. Now you have your chord length, which is the same math that we have if we use the law of cosines. So now we have the 60-foot radius, we have 26-degree angle. Now we have the opposite. Now let's try to find the the adjacent here. This is the adjacent length to right here, 539276. So how do we get that? So that would be the cosine, or we can, now that we have this, we could also use the tangent. So let's start with cosine because we already had that. So 26 degrees. Now the cosine is where they connect. That's where this angle and that angle connect. And that's going to be cosine 0.8988. And now we're going to go 60 times, and that is 539276. So that is the adjacent distance to here. Now, we already know it's 60 feet all along this arc here. It's a 60-foot radius. And we have this distance here to here. So now if we subtract that distance, 539276, from the radius, 60 minus 607, 6.0724, that's your mid-ordinate distance right here. So now we've solved that. And what else did we have? I think that's all we have. That's all we really need right there. We could also do this by tangent if we want. We can go 26, and we can go tangent, and then 26.3023, 26.3023 times, oh no, we want to divide that now. That's right, because, okay, so we want to go 26, enter, we're going to go in, oh, I said I didn't do that, so sorry, sine, no, we want to go tangent, I didn't do that, tangent, and we want to inverse that, 26.3023, and times 539277 is what I got because I did use my store number, so that's it. So what I do there, 26 degrees, I used the sine, I did the inverse on that, which gave it multiply, and then multiply it times that. Okay, or you could divide, do that backwards. So that's how you solve those, and we have all that curve, and that's what we did before. We've solved everything on that you can solve really from those simple things. So now in the calculators, you have a function here under key 9 on the HP35S. And then you have to look at your own calculators to see what you have on there for converting radians to degrees, degrees to radians. On the free 42, that downloadable one, that app that I've been talking about ever since this course started, they also have it, and you'll find that under the convert, convert, it's down here somewhere, it's a convert. It's the same one you use to convert hours, minutes, seconds to decimal degrees. It's the same, and you'll find it over to the left. It's the left 2 instead of the right 2. So you can do the same thing with that one that you can do with this one. Very, very good program they've written there. Okay, so radian, what a radian is, and we talked about this on the last one where we did start to talk about radians, and we did work a bunch of it out. A radian is the radius, so in this case it's 60 feet, subtended on the circumference, or overlaid on the circumference. So you would have 60 feet overlaid on this one here. So if you go into your data collector, let's see, so if you go in your data collector and put in 180 degrees, just enter 180, and then go to your key where it says it's shift key, left shift key, and hit 9. It's going to come up with 3.1416, so that's pi. So that's showing you 1 radian is pi 180, pi times 180. 2 radians is 360, so you would enter 3. This is just a check, just to show you how it works. 360, enter, hit radian, and it's 6.2832. There it is right there. So 2 radius, so 2 radius is 360, 1 radian, and don't get confused, radian and radius. Radian is the radius subtended on the arc. And let's see, radius divided by the circumference. Now there's also an angle involved, and the angle is going to be the same no matter what radius you have, because it's all going to be a percentage of the circumference. So in this case, we'll use this one here. Radius divided by the circumference is going to be this right here. So we'll do that. Radius divided by the circumference, 60. In this case, it's 60. The circumference is, recall 1, divide, and now we want the, then now we want to go 360 degrees. So we got 0.1592. Then we go 360 times. This is 57.2958. So they usually round that off to 1. So one angle of radian is 52.3 degrees. That may or may not come in handy at some point, but that's how you do that. And again, it's that same ratio of dividing the circumference by the curve length or dividing the degrees by the angles to get your percentages so that they coincide with each other. Okay, now to convert. If you're doing a test or if you're just trying to convert, figure out what your curve length is, or you have the curve length, you're trying to figure out what your angle is, you have your calculator. I think we already did this. Yeah, enter 180, shift, and you're going to get 3.14. Enter 360. That is left shift on here. That would be the gold key. And then 9 means that I just highlighted the 9 key has the radian highlighted above it and degree highlighted below that in blue. So if you enter 360 degrees, left shift, key number 9, that activates the radian function, the radian conversion, and then you have 6 points. So that's 2 pi. So one of the things you can, to get your diameter, you can go 2 times the radius. In this case, when you're dealing with radian, they don't double the diameter. They don't double the radius to get the diameter. They hold the radius and they just double the pi, 2 times pi. Play around with that until that makes sense. All right, now you want to convert angle to curve length. All right, well, our angle on this particular one is 52 degrees. That's our delta. We're not dealing with the right triangles. We're dealing with the delta, and we need to know that curve length there. So you want to enter, this is my symbol for angle, 52 degrees, and you want to use that same shift key, 9, radian, and then you want to multiply it times 60. So let's just do that here. 52, enter, and then we're going to go shift, radian, 0.9076, and what do we want to do? And then you want to go 60, you want to do the radius, and then times. And that's 54.4543. That's the curve length. So now you have the curve length. Very simple. Very quicker than doing it the long way around. My preference, though, is do it both ways until you become very conversant with either one or with both of them. Use the other system to check. Do it this way and then use the long version to check, or do the long version and use the radian system to check. Now, if you want to convert this one, kind of the same thing. Yeah, curve length to angle. You're going to convert curve length to angle. You want to enter your curve length, which is 54. I think I have that stored. Recall 2. And then we want to go to degree. Now it's the same key. It's the 9 key, but now it's shift. It's the blue shift key. And that's giving you 3120.000. And now you want to hit the radius is 60 feet. So 60, and this time you want to go divide instead of multiply. That gives you your 52 degrees. And that's how you do the radians, and that's how you can use the radian. So a radian is the radius subtended on the arc times, and then, well, you got it. I already told you that. So that's it. We've solved that again. You should have your horizontal curves. Enough of that so you can work with those, and you can certainly go on from there, but that gives you the basics that you're going to need to know. So that's all for lesson 24, and someone told me I'm missing 19 out of my YouTube files, so I'll go look for 19, see what happened there if I actually got deleted. But anyways, next one will be 25, and I think we're going to learn to do a resection now. All right, thank you very much, and please like and subscribe.